Thank you, Ed. We're going to go over a short demo of the Tanzu RUN, how to run Kubernetes as part of vSphere, and how to run Tanzu Kubernetes Grid on top of that Kubernetes platform. Now, I'm going to use an application called Acme Fitness App. It's an open source. You can check out the GitHub of the application. It's just a polyglot application that has different components with different languages and different backend services. So we can see Mongo and Redis as the backend. Now the architecture that I'm going to use is basically using vSphere with Kubernetes to run native pods or pods of Kubernetes running directly on the ES6i. And from the other end, the front end of the same application will run on Tanzu Kubernetes Grid cluster that is upstream, aligned, and conformed Kubernetes cluster. And I will show how do you actually address those two different constructs while leveraging those two different platforms, addressing that in the same operational perspective inside vSphere. Now, the main reason you will run native pod directly on vSphere is because you will get better performance than anything else. Those pods that is running directly on the ES6i will run better because the ES6i was evolving for the last 20 years in making better calls to CPU and memory. So you will get 30% better performance than running on the VM on the right side, but you also gonna get between 8 and 10% better performance than running on bare metal. Now it's just not just from compute perspective, it's also from storage, because when you're using software defined storage, that data is in the same ES6i that the pod is running. So it's basically leveraging those physical capabilities from one hand when you're running that backend services, and leveraging the open source community capabilities and the conformancy clustering in Tanzu Kubernetes Grid to run the front end and scale and do basically whatever you need on the Kubernetes side. So let's jump into the demo. So what you see right now in my screen is my vCenter 7. It's a GA version. That's the vSphere 7 with Kubernetes. You can see I've onboarded my cluster, so you can see namespaces. That is basically a new construct. It's just like a resource pool in the VI admin world. And if I will open that, you will see different namespaces like Acme, Demo, Grid clusters. And you also see 3 virtual machines. Those are the control planes of the Kubernetes cluster. So when I'm interacting with kubectl API, I'm interacting with those clusters. Now, if I will hover above the Acme namespace, you will see different aspects of just visibility of information from that namespace. You can see the status is healthy, it's running. There's permissions for developer user to view, and there's permissions for administrator to edit. And there's a storage persistency that is basically bonded to the namespace. Kubernetes storage policy is the policy that is connected into that specific namespace. It has a limit of 10 gigs. And if I will go down, you will see there's a capacity and usage quota, and that is basically applied on the namespace. Now, those quota, CPU, memory, and storage, are applied on the namespace regardless of the object that is inside that namespace. If I will expand that namespace, you will see that inside there's different pods. So you can see users Mongo, orders Mongo, catalog Mongo, and carts Redis. But from the other end, there's also Acme Cluster 1, and Acme Cluster 1 has virtual machines, and that's the Tanzu Kubernetes Grid cluster. When I'm applying policies here, if it's quota policies, storage policies, or permission policies, it will be applied on both a cluster, Kubernetes cluster, and Kubernetes pods. Now, if I will go and get into compute, you can actually see the pods that is running inside that namespace, and you can see only the backend services. You don't see the front end because the front end is running inside the Acme Cluster 1. But you can see the backend services, and if I will click on View YAML, you can actually see the YAML file of the pod itself, and you can also see deployments that is running in the backend. But there's also a Kubernetes cluster running in the same namespace. So if I will go to VMware resources, you will see Tanzu Kubernetes Grid cluster that is running. That's the Acme Cluster 1. And you can see virtual machines that is running as part of that. Now, if I want to interact with that cluster, I would probably do that as a developer or DevOps with a command line. So if I will go on the right side of the screen, you can see I'm interacting right now with my supervisor cluster. If I will do kubectl get namespaces, I will see all the namespaces that I'm seeing on the left side, but now I'm interacting with kube control. Now, if I will get pod in the namespace Acme, I will see the backend services. I want to change my context so I can actually interact with the Acme cluster 1 and show you the application itself. So I'm going to use context Acme cluster 1. And now when I'm doing kubectl get ns namespaces, I'm getting different namespaces. And that's a different cluster. So if I will do kubectl get pod in the namespace Acme, I will see different pods, and you can see I have a front end here. That's the front end of my application. If I want to see how the application is exposed, I can do kubectl get svc in the namespace Acme, and I will get the external IP. Now that IP is resolved by acme.lab.local. So if I will browse acme.lab.local, I will get into my application. So let's do that. And I will browse acme.lab.local. You will see my Acme app. Now, as I said, the front-end services are in the Tanzu Kubernetes grid, but the backend services is utilizing the best of the platform of Kubernetes with vSphere from compute perspective, storage perspective, and everything else. And that application, when I'm managing that as a VI admin, I'm managing a namespace in vCenter. So I can apply different policies, quotas, and address that construct. If I have like just a couple of more minutes in it, great. So I want to show you Tanzu Mission Control, and in Tanzu Mission Control, you can see different clusters that I'm managing. So I'm managing vSphere clusters, AWS clusters, GKE clusters, Azure clusters, and so on and so forth. It's a single control plane for any conformant Kubernetes clusters that you need to manage. But from the other end, you can also provision clusters from that control plane. So we can create cluster with an easy button on AWS, let's say for an example. Now we can see Acme cluster 1. So that's the cluster that I've demoed. And if I will click that, you will see a different operational perspective information on that cluster. So you can see it's vSphere, that's the version of Kubernetes, the amount of worker nodes, and the health state of Kubernetes. And you can see the health state of the agent of Tanzu Mission Control. Now, if I will go to namespaces and I will click on the Acme namespace, just like I've shown in the demo, I will see then different deployments and replica sets that are inside of that. And if I will click on front end, let's say, I will actually see the YAML file that was part of the declaration of the YAML of the front end. So I can, from the operational side, see everything that I need on the cluster. But it's not just that. Tanzu Mission Control has the capability to basically create different hierarchies. So you can create cluster groups, let's say production and development, and you can then apply policies on those constructs from access policies, image registry policies, network policies, and security policies. And all of that different policies, let's say like identity, are consistent across any conformant Kubernetes cluster that you're managing. And by doing that, it's really easy to understand what's the identity of each cluster, and you don't need to get into different consoles to basically align the identity and the access. You can do that from a single point. And another important issue, and that's the last thing that I will talk about, is the conformancy test. So you can do with Tanzu Mission Control also different inspections of those clusters. Let's take the GKE for example. You can see there's an inspection that was running. It's a CIS benchmark, so it's a security inspection. And if I will view the inspection, I can see what's wrong and I can take care of that. I can fix that. And I can do that again across any cluster, any conformant Kubernetes cluster. So that's Tanzu Mission Control. There's a lot to basically get into, but that's the amount of time that I have, and I want to thank you for the demo.